to this inequality. So let's go ahead and copy that down here as well, so we can get a look at the whole happy inequality family. So that's the solution to that inequality. Copied the text too. That's cute. And I copied my hands too. Alright, just a second. Alright. So we see the solution to that inequality right there. And you'll notice how we turned, again, I cannot stress this enough, obviously, how we turned this one inequality into a two-part compound inequality. Alright, let's try one more example. Let's ask ourselves, what are we going to do if we get an inequality that looks something like this? Absolute value, 3x plus 4, for example, is greater than or equal to 71. And you will be like, oh wait, this is different. Because these other ones, we started out with a less than inequality. And now we have a greater than, and just happens to be a greater than or equals to inequality. But hey, have no fear. Follow those steps. Ask yourselves, what does absolute value mean? And what does it mean to have an inequality like this? It means if I take a number, if I take some number x, and multiply it by 3, then I add 4 to it, that number, whatever I get, should be no further away from 0 than 71. So that means that, it should be further away from 0 than 71. Remember, this is greater than or equal to. It should be at least 71 units away from 0. Which means that 3x plus 4 can either be greater than or equal to 71, or 3x plus 4 could be less than or equal to negative 71. It can be either one. Notice how it can't be both at the same time, so it wouldn't make any sense to make a compound inequality look like this. Because you can't be greater than or equal to 71 and less than or equal to negative 71. If you don't trust me, grab a number line and try it out for yourself. So you'll notice that in this situation, we can't make a compound inequality. That's the product of having this greater than sign going on. But we do have two pretty easy to solve inequalities. So we're just going to go ahead and solve them one at a time. Remember, this is an OR situation. It can be one or the other. Whereas in our other compound situation, we had kind of that and. We had to be both, had to be two conditions at the same time. Good. So let's go ahead, take a minute, pause the video, and try to solve the inequality for part 1. You can check your answer when you come back. So pause the video now. Did you actually pause it? You should have actually paused the video. Alright, we're going to go ahead and check that answer right about now. Should have said, hey, 3x plus 4 greater than or equal to 71. I'm going to go ahead and subtract 4 from each side of this inequality. I'm going to get 3x is greater than or equal to 67. And you're going to say, okay, divide both sides by 3 and get x greater than or equal to 67 over 3. We love improper fractions. They're all proper to me, you know what I'm saying? Alright, so there's one solution. But hey, brace yourself. There's more cowboy or cowgirl or cow alien, whatever you might happen to be. We still have the second part going on. Let's get down to business. 3x plus 4 less than or equal to negative 71. And we can go ahead and just say, okay, that means that 3x, if I subtract 4 from both sides, less than or equal to negative 75. I divide both sides by 3 and I get x less than or equal to negative 25. So, here are my solutions. x can be greater than or equal to 67 thirds, or it can be less than negative 25. And that just about does it. If you now understand these principles, you can try to solve any, and I do mean any, absolute value inequality you come across. Right, so let's recap what we did here. We start out with some absolute value inequality, which looks something like this. We ask ourselves, what are we actually doing here? What does absolute value actually mean? Draw a number line if it helps. Then we set up new inequalities. We either get a compound inequality, or we get two different inequalities based on the situation and based on what, how the greater than or less than signs apply in your given situation. And you don't have to remember any sort of tricks if you just remember what absolute value is actually saying. As long as you remember that, you won't have to remember any tricks. You won't get confused about anything. And then we just go ahead and solve regular old inequalities. Maybe they got parts like the compound ones. Maybe they just are two separate ones with two parts each, like the OR solutions that we get down here. Alright, what I want you to do is I'm going to put up a few problems. Go ahead, try them out. Pause the video after I put them up, and you can check your solutions. I'm not going to show written out work, but I will just quickly, poof, there will be solutions. It'll be pretty cool. Alright, so what I want you to do is go ahead and try to solve these inequalities. Absolute value of 3x plus 9 is less than 42. Number 2, the absolute value of negative 5x minus 1 is greater than 7. And 3, the absolute value of 9x plus 4 is greater than or equal to negative 9. Alright, go ahead, pause the video, give it a shot, and I'll see you on the other side. And we're back! Hopefully your answers look something like this. For 1, you should have received the lovely response that x is between negative 17 and 13. For number 2, you should have found that x is greater than 6/5 or less than negative 8/5. And you should have found that number 3 can't be solved because you immediately do your first step and you say, okay, so that means that 9x plus 4 has to be a distance from 0, which is, remember, negative 9. You can't really have a distance of negative 9, so it doesn't make any sense to say, oh, you are more or less negative than negative 9 away from 0. So you should have found problem number 3 to be quite the mind-boggler. Alright, if you didn't get these results, check them again. Be sure to go back and check out the steps we take in solving a problem like this. If you did, congrats. You've earned it. On the flip side, I'll catch you later. This is Mr. P, keeping it as real as possible.